What's up, guys, and welcome to this video on question 9 of the 2016 final exam. This question has to do with photons and electrons, and it's worth 14 marks, so it should be pretty quick, and hopefully we can get lots of marks. Okay, so question 9.1. Okay, so the work functions of selected metals are recorded in the table below. Take note of the units of the work function. It is times 10 to the negative 19 joules. Okay, so we have sodium, aluminium, zinc, and iron. Okay, so we start off with a definition. Define the work function. Okay, so the work function is the minimum amount of energy needed to emit an electron from the surface of a metal. Okay, so if the energy is less than the work function, then no electrons will be emitted. Okay, so I hope that makes sense. So that might come in useful later. Okay, so we're moving on. Light of a wavelength, let's say lambda, is equal to 296 nano, which is times 10 to the minus 9 meters, is incident on a sample of each metal in turn. Calculate the energy. So 9.2 says calculate the energy of a photon of light of that wavelength. Okay, so we can use the equation E equals hc over lambda, where h is Planck's constant and has a value of 6.6 times 10 to the minus 34. C is the speed of light and has a value of 3 times 10 to the 8. And lambda is the wavelength, which was 296 times 10 to the minus 9. Okay, if we plug this into our calculator, we get the answer of 6,69 times 10 to the minus 19 joules. Okay, so this is how much energy the energy of the photon. Okay, so this is the total energy available, basically. Okay, so which metals listed in the table will emit electrons at this wavelength? Okay, so basically, remember the work function is the minimum energy. So anything more than this energy right here will result in nothing being emitted. Okay, so 6.9 is greater and 7.2 is greater. So we're left with these two. Okay, so basically we have enough energy because 6,69 is greater than 3,94, and similar 6,69 is greater than 6,53. So there's sufficient energy to release electrons. Okay, so basically our answer for 9.3 would be sodium. Sodium and aluminium. Okay, cool stuff. And we get 3 marks and 2 marks. Okay. And then it says, calculate the maximum kinetic energy of the electrons. So we want the maximum kinetic energy ejected from the sodium metal, okay, when that wavelength of light. Okay, so we're looking at sodium. Okay, so 9.4, let's do it here. Okay, question 9.4, we're going to use the equation H. Okay, so remember we want kinetic energy, EK. So we can use the equation HF is equal to the work function plus EK max. Okay, because remember we want the maximum kinetic energy. Okay, so we know what H is. Okay, so H is equal to, we know what this is. Okay, because this is our energy. So this is what we calculated right here. These two right here, because this equation is also equal to HF. Okay, so HF is what we calculated, which was 6,69 times 10 to the minus 19. Okay, again, if you don't know where that's from, this value that we just calculated is the total energy, is equal to the work function, which is 3,94 times 10 to the minus 19 plus EK max. Okay, the only unknown in this equation is EK max, so we can solve for EK max quite simply by minusing the two values, and we get that EK max, or the maximum kinetic energy, is equal to 2,75 times 10 to the minus 19 joules. Okay, and we get 3 marks for that. Okay, so the last question, it looks like a theory question. The intensity of the 296 nanometer light is now increased. Okay, intensity is increased. Will the light now be able to eject electrons from the other metal listed in the table? Briefly explain. Okay, so this is a full-on theory question. When the intensity increases, the frequency remains the same. So we can say straight away, we can just say no, because the frequency stays the same. Okay, and if we look at our equation, E equals HF, if the frequency stays the same, the energy is not affected. So energy is not affected by intensity. Okay, so basically we can give that answer. So we can say no, using that equation, F is the same. So energy is not affected by intensity. Okay, so basically what we're saying is we don't get any extra energy because the frequency of the light stays the same. Okay, alternatively we could say no, the intensity increases, so the intensity increases the number of photons, but the energy of the photons is not affected by the intensity. So it increases the number of photons, but the energy of the electrons does not change. So yeah, so either of those answers will work. You guys can just pick, but that's the answer that I've written down. Yeah, okay, cool stuff, and we should get 4 marks for that. Yeah, and that's our 14 marks. Yeah, cool stuff. Yeah, and that's the end of this paper. So cool stuff, guys. Thanks for watching, and I hope you found this useful. Okay, cheers.